Welcome to Mathematics Online Lecture Series, lecture number 9. Change of variables in double integral. Nothing but Cartesian form to polar coordinates. By Professor K. V. Narasimhan, London Institute of Engineering and Technology, Vijayanagara. Today, we will discuss about a new concept, change of variables from Cartesian to polar coordinates. For evaluation of double integrals, suppose if the given double integral in Cartesian form is nothing but in terms of x and y. In terms of x and y, sometimes it is very difficult to find it. It is very difficult to find the double integral. In that situation, you may change into the polar coordinates. In that situation, the double integral evaluation of double integral is very easy with the help of polar coordinates. Now, what about the polar coordinates? Suppose if you observe on the screen, suppose if you observe, this is the x-axis, this is y-axis, which is shown here also. Suppose if you take any point a comma b, this is x-axis. How to change the coordinates from Cartesian form to polar? Now this is in Cartesian form. Now suppose if you take any point a equals to a comma b, is nothing but, suppose if you take a perpendicular line to x-axis, this point is foot of the perpendicular of a, nothing but a comma 0. In the similar way, take the foot of the perpendicular from this point to y-axis is nothing but another point, some 0 comma b. Okay, here j a comma 0. Suppose if you join these 2 points, this is origin and a. So theta is the angle between x-axis and this straight line. So observe this the diagram. This is called radius vector. Okay. Now how to change the Cartesian form to polar form? Here this value, this is a, this is b. Assume r equals to square root of a square plus b square, then no problem r. Now if you change into the polar coordinates, what is cos theta? Cos theta equals to, what is cos theta? What is cos theta? Cos theta equals to a by r. Sorry, a by r. Okay, correct. Sin theta equals to b by r. From this one, a equals to r cos theta, b equals to r sin theta. Suppose if you assume this point is any point x comma y, then what happen? Any point x comma y in this coordinate axis, in this coordinate plane, then x equals to r cos theta using the same, y equals to r sin theta. Now this is a simple transformation from Cartesian to x in terms of xy to in terms of polar coordinates r comma theta. X equals to r cos theta, y equals to r sin theta. Now what happened? This point becomes r cos theta, comma r sin theta. R cos theta, comma r sin theta. What is r? R is the radius vector here. Theta is the angle between x-axis and also y. In polar coordinate, x-axis is called initial line, and y-axis is called vertical axis or vertical line. Now dx dy equals to, we have a beautiful formula, dx dy equals to r dr d theta. So we have another formula actually, dx dy equals to Jacobian into dr d theta, dr d theta. So Jacobian value is r. So if you find the Jacobian, you will get r simply dx dy equals. At this moment, just you learn dx dy equals to r dr d theta. Now coming to the problems. Today we will discuss three different problems for changing into the polar coordinates. First problem, evaluate double integral 0 to infinity, integral 0 to infinity e power minus x square plus y square dx dy by changing into the polar coordinates. Hence deduce integral 0 to infinity e power minus x square dx equals to root pi by 2. We will discuss later. First, we will evaluate this integral by changing into the polar coordinates. Actually, this is very difficult to find suppose this is x equals to 0, y equals to 0. X limit 0 to infinity, y limit 0 to infinity. If suppose if you integrate e power integral 0 to infinity e power minus y square dy it is very difficult to find the value. In time, suppose if the integral in terms of xy. Now change into the polar coordinate. Now it is very simple. Now now we will discuss about the solution of the first question. So now this is the given problem. Now observe this one. This is x limits integral 0 x is 0 to infinity. How to find the limits? How to find the region using the given problem? So next one is very simple, e power minus x square. So direct given integral dx dy. Okay. Now what about the region? This is x-axis, this is y-axis. Okay, y is 0 to infinity. Y is 0 to infinity is nothing but this line. Y equals to 0 is nothing but x-axis. This is y equals to 0, 0 to infinity. Okay. Now again x equals to 0 to infinity. X equals to 0 means y-axis to this one. So what about the region? Totally first quadrant. First quadrant is the our region R. Our region R. This is our region R. Now change into the polar coordinate. Now first observe the region. This is our region. This is the total region is our region. Now we will change into the polar coordinate. Then we will discuss the limits. Again we will discuss the limits. By changing into the polar coordinates, by putting x equals to r cos theta already discussed and y equals to r sin theta, dx dy equals to r dr theta. Now what about the limits of r and also limits of theta? R limits. Now r is nothing but radius vector. This is the radius vector. It is moving all the directions. Now initially r value is 0. Now 0 to up to infinity. R radius vector starting from this point to the nothing but r is 0 to infinity. Now what about the angle? Here starting initially theta is 0 up to y-axis theta becomes pi by 2. Very simple. Theta equals to 0 to pi by 2. 0 to pi by 2. R limit 0 to infinity, theta limit 0 to pi by 2. Now substitute all these results in the given integral. Now we will evaluate the given integral, double integral. X is 0 to infinity, y is 0 to infinity, e power minus x square plus y square dx dy. Now r value already known, 0 to infinity, theta is 0 to pi by 2, e power x square plus y square. X equals to r cos theta, nothing but x square cos square theta plus here y square. Y square means r square sin square theta. R square sin square theta. If you common in these two terms, r square into cos square theta plus sin square theta is r square. That is e power minus r square. Dx dy is already known, r into dr dθ. First separate the r terms and then integrate with respect to r, then integrate with respect to theta. Now first integrate with respect to r. Separate the r terms. Now it is very simple. Multiply and divide with 2. Multiply and divide with 2. Now this is 2r. Now 1 by 2. Integral theta is 0 to pi by 2. Integral r is 0 to infinity e power minus r square into 2r dr. Suppose if you assume t equals to r square equals to t, dt equals to 2r dr. Now this integral becomes e power minus t. E power minus t dt. Integral value is minus e power minus t. T is already known, minus e power r square. Now this is minus e power minus r square. 1 by 2 times of integral theta is 0 to pi by 2 e power minus r square. Now substitute, put theta equals to r, theta equals to infinity, e power minus infinity. And put theta equals to 0, minus or minus plus theta 0, e power 0. Now e power minus infinity is this quantity is 0, this quantity is 1. That's why 1 by 2 times of integral 0 to pi by 2, 0 plus 1, 0 plus 1 d theta, d theta. Now adding the 0 plus 1 is nothing but 1. Again integrating with respect to theta, integral theta is integral d theta is integral d theta is theta, limit 0 to pi by 2. Then what happened? 1 by 2 pi by 2 minus 0. 1 by 2 into pi by 2 minus nothing but pi by 4. So hence double integral of integral 0 to infinity e power minus x square plus y square dx dy is pi by 4. Actually, if you integrate with respect to in terms of x, y and x and y, it is very difficult. If you change into the polar coordinates, now this integral is very easily we can evaluate the integral value with the help of polar coordinates. Now deduction. The deduction is very simple. Now we will find this integral value, integral 0 to infinity power minus x square, assume this is I. Now this is the definite integral. If you replace x by y, you will get the same I. Multiply these two, I into I is I square equals to integral 0 to infinity, integral 0 to infinity power minus x square is here. Now common these two terms into integral 0 to infinity, integral 0 to infinity e power minus x square into e power minus y square is nothing but e power minus x square plus y square. This value is already known, just we evaluated the value pi by 4, pi by 4. I square equals to pi by 4, I equals to root pi by 2. I equals to root pi by 2. Now this is the deduction of the first problem. In the similar way, we can find the second problem. Now second problem is also similar problem. Evaluate double integral 0 to infinity, integral 0 to root over a square minus x square, y into root over x square plus y square dx dy by changing into polar coordinates. So directly it is very difficult to find the integral value. Suppose if you apply polar coordinate, now it is very easy. Now what is the solution? Now observe the integral, same integral. Here in terms of y, so this is the limit of y, other variable is x0 to infinity. This is given problem. If the limits are in terms of x, now this becomes y, other variable is x here. Okay. Now if you observe y equals to 0, just observe x-axis and y-axis. Y equals to 0 is nothing but x-axis. I will write here. X-axis, y equals to. And also y equals to root over a square minus x square. A square minus x square. Squaring on both sides, what happened? X square plus y square equals to a square. It represents a circle. It represents a circle. It represents a circle. Now what about our limits? Y is 0 to this circular curve. This curve is y equals to root over a square minus x square. 2 square minus x square. Now x limits. Now this is point is a comma 0 because a is the radius, a comma 0. X limit, if you observe the problem, x limit is 0 to a, x is 0 to a means this region only. The circle in xy plane only. The region between x-axis and y-axis, which is shown in this diagram. Now changing into the polar coordinates. Now again, x equals to r cos theta, y equals to r sin theta, ds dy equals to r dr d theta. Now what about the y limits and x limits? R limits and r limits and r limits and theta limits. Now what about the r limits? So here the curve is y equals to x square. The given curve is x square plus y square equals to a square. X square plus y square equals to a square. X square is nothing but x square cos square theta plus y square sin square theta equals to a square. If you simplify r square is the common to r square into 1 equals to a square. Now r becomes a. So this curve is nothing but r equals to a. Now what about the radius vector? Radius vector, r value, initially this is 0, 0 to a. R varies, r limits 0 to a. 0 to a angle, 0 to a, angle theta. Here theta is 0 to 0 up to this angle. Now radius vector moving along this curve up to this one only. Here theta is pi by 2, 90 degrees. So theta varies from 0 to pi by 2. Third problem is also same similar limits. Okay. Now r limit 0 to a, theta limit 0 to pi by 2. Now observe. Now we will evaluate this double integral. Now theta is 0 to pi by 2, r is 0 to already discussed. Now y is nothing but r sin theta. Root over x square plus y square is nothing but r. Dx dy equals to r dr d theta. Now here r square r cube into sin theta dr d theta. Double integral of theta is 0 to pi by 2, r is 0 to a, r cube sin theta dr d theta. Now theta is now separate the r terms and theta terms. R cube integration is r power 4 by 4 in limit 0 to a. Now put theta r equals to a, then r equals to 0, a power 4 minus 4. What happened? A power 4 by 4 minus 0 is nothing but a power 4 integral 0 to pi by 2 sin theta d theta. Sin theta integral value is sin theta integration is minus cos theta. Minus cos theta. Minus cos theta. Now a power 4 by 4 minus cos theta limit 0 to pi by 2. Put theta equals to pi by 2. Cos 90 is 0. First term is 0. Now minus or minus plus. If you put theta equals to 0, cos 0 is 1. 0 plus 1 is 1. A power 4 by 4. So double integral 0 to a, y is 0 to root over a square minus x square, y root over x square plus y square dx dy equals to a power 4 by 4. In the similar way, third problem, now observe the third problem, limits are same. Limits are same means diagrams are both are same. Limits are in terms of r theta, limits are also same. Integrand is different integrand. Now we will evaluate double integral 0 to infinity integral 0 to a square root of a square minus x square plus y square dx dy by changing into the polar coordinates. This is x, this is y, because in terms of x this becomes y. Now this becomes x. Now same procedure. This is x, this is y. Y is 0 to already discussed. Y is 0 is nothing but this one. Now y is 0 is nothing but x-axis, and up to this curve is up to circular curve already discussed in the earlier problem. This one again shaded region is same. Now changing into the polar coordinates, x equals to r cos theta, y equals to r sin theta. Then what about the limits? already discussed r is 0 to a. Already discussed in the earlier problem, 0 to a, theta is 0 to pi by 2. 0 to pi by 2. Okay, fine. Now changing into the polar coordinates. Now this is the given integral. Now theta is 0 to pi by 2, r is 0 to a. This is x square plus y square is already discussed earlier. That one is r square. ds dy is r dr d theta. R square into r is r cube. This is same as our previous integral. R cube integration is r power 4 by 4. So put r equals to a and r equals to 0. We will get integral 0 to pi by 2 a power 4 by 4 minus 0 d theta. A power 4 by 4 is the common term. Here in the previous problem it contains sin theta, but here only theta, d theta. Integral d theta is theta, limit 0 to pi by 2 minus 0, nothing but if you substitute theta equals to pi by 2, then minus 0 pi by 2 into a power 4 by 4. A power 4 by 4 is nothing but a power 4 by 8. So I think this is clear. If you have any doubts, ask me through my email or through my WhatsApp number. So thank you very much. Enjoy. Meet again.